Welcome to the Trellix Spotlight series. My name is Nick, and I will be your host. Today's session will focus on leveraging EDR integrations into SOC processes to build a better defense. This webinar will be recorded. If you prefer not to participate in the recorded session, please feel free to disconnect at this time. A link to today's recorded presentation will be emailed to all registered attendees. Without further delay, let me hand it over to Matt for our presentation.
Thanks, Nick. Today's webinar in our Trellix Spotlight series will be covering integrating EDR into SOC processes for a better defense. One disclaimer before we start, this webinar is a brief overview covering the common trends, use cases, demos, and scenarios regarding this topic. It's not intended to be all-encompassing, as it's not possible to cover all detailed scenarios in one hour webinar. If assistance is needed, please contact Trellix Technical Support. Before we get into the webinar, we'll have an introduction of myself, and then we'll jump into the module enhancing defenses using EDR features and integrations. Within this module, we'll have subtopics such as using real-time search features for triage and DFIR activities, investigations and historical traces to expand visibility, and then finally, Trellix native XDR and external API integrations to help automate responses and increase intelligence. When we're finished with the module, we'll have a conclusion, and then finally, we'll have some Q&A left over at the end of the webinar. A little bit about myself. Here I am. I'm Matt Smith, the Senior Manager with Trellix Professional Services. I've been in our North America division for over 14 years now, and I've been at Trellix M or McAfee for 17 plus years. While I've been in professional services, I've delivered services for over 200 organizations worldwide across multiple verticals, including governments, telecom, medical, tech, entertainment, and many others. When I have delivered, I've delivered on various types of services, such as assisting with regulatory compliance, incident response, focused product training, product use case development and delivery, and then finally program development. My product and domain expertise is, of course, endpoint detection, response, and defense. I also cover security event management analysis, or work with SIEMs and SOARs, database security, and finally, vulnerability management. With that said, we'll just jump right into our main module here, enhancing defenses using EDR and integrations. And our first topic is discussing how to use real-time search and responses. Within here, we'll discuss some common use cases for built-in and custom collectors and reactions. Why is real-time search and responses important to a SOC and the analyst in the SOC? Well, first of all, it's understood that you'll need to search quickly across running systems without the need to log in directly. And EDR gives you just that. You don't have to provide extensive ways to access these systems because they have a client that's going to be sending information up the cloud. And you'll be able to use the product's functionality to query these systems for information, as we'll see later. When using real-time search, we want to be able to acquire data to support hypotheses that of what might be occurring in our environment. It could be that there is an actual attack, or it could be that there's just normal processes that exhibit the anomalous behavior, and we just want to make sure we rule those out. You may want to use a product like this to execute other tools and scripts that may support your DFIR needs. This could include things such as putting the system into a quarantine state, getting information about what registry keys are installed, what processes are running, other things like that. Or it could expand beyond that to use other tools that we'll discuss a little later on in this module. And then finally, if you want to perform any triage or cleanup activities, meaning we're going to correct what's been broken or remove files, whatever you need to do to make the system go back to its original state, then a tool like EDR certainly can help with that. Let's understand a little bit about the real-time search internals before we get into what we can do with real-time search. First of all, real-time search relies on, of course, the combination of the client plus the EDR cloud. The EDR cloud accomplishes what it needs to accomplish because it has the ability to communicate to those systems, or rather the systems will be able to communicate to the EDR cloud. Depending on what type of environment you've set up, if you've set up a MVISION EPO environment, which is all cloud-based, or you've set up a on-prem environment where you may have components like DXL brokers installed. Either way, the clients eventually connect to our DXL gateway in the cloud in order to exchange messages between the EDR cloud and the clients. When exchanging messages, it's the clients that hold the cloud for any new updates, including scripts that may be used in doing data collection and reactions, as well as any messages that you may send as far as traces or activities on the system that will be submitted to the cloud. So at any point, the cloud is not directly giving you these things without you actually asking for it first. When we do searches, we start in the cloud, of course. This is where we're going to post the information that the clients will eventually pick up in a few seconds after they do their polls. And when we want to collect information or gather information for our real-time searches, we use what's called a collector. Now, a collector at its most fundamental understanding is a client-side script that can be written in either Python, PowerShell, shell language, so whatever bash shell, whatever you use for Mac or Linux, and then of course Windows and Unix and Mac operating system commands. One thing to note is that whatever you write in that particular language, that the clients have to be able to interpret it. So if you don't have, say, a Python client on a Windows system, or you have a Python client on a Mac system that is at a lower level than what you have scripted for, meaning you've written a script in version 3x and you only have a 2x client, then you have to bring up that compatibility on your own. For that, we don't have an interpreter that we add with our EDR client at this time. When we're collecting information, we like to refer to the information that we're collecting as part of the ring buffer. So it's information about the system that could be useful for the purposes of threat hunting and understanding what it is that's occurring on the system. Some of these are listed here in the box to the right. There would be some things like processes, APIs, browser histories, registry key changes, file hashes and changes, user logon events, and with our newest Linux client, we can collect things like kernel module loads and unload events, and even more. Now that we understand a little bit about the internals at a basic level about how the client acquires its information, it acquires new scripts, pulls this down from the cloud. Now, what do we do when we actually want to execute against use cases in our threat hunt? First of all, there's no overall manual or book that can give you from Amazon that gives you all this. Would be nice. But we do have in our product guide a section called built-in collectors and reactions, which have many examples of what we have built into the product. So those examples cover syntaxes, they cover operating systems that the collectors will run on, and then other caveats about when running those scripts. Those are all built in for you. You don't have to make changes to those, and they're given to you as a part of the EDR content that you would receive from us and any updates to the product that we have. We do have a Trellix supported GitHub. Currently, it is not branded Trellix. This may change soon, But you can search for McAfee Enterprise, GitHub, and real-time search to find the section that contains these real-time search queries. The real-time search queries are divided into two categories. The first category is focused strictly on hunting and indicators of attack. So, for instance, if there was an indicator of attack that, let's say, might be Cobalt Strike, for example, if we had a script there or a search example, then we can show you that search example based off of that, and you can search for evidence of Cobalt Strike in your environment. Orientation is yet another section in this GitHub that'll allow us to look at any other. So if you're looking for software versions, you're looking for process history type requests, scheduled tasks, anything of that nature. They do have a number of examples that you can simply copy and paste and make changes to adapt to your own needs. In our first use case example, using real-time search, I simply want to take a look at what happens when an application launches command line that accesses a remote IP address. So maybe a script gets ran, or maybe an attacker is trying to do some lateral movement in order to get out of your environment and do exfiltration, whatever the behavior is. First thing, obviously, I would look for command line history. It's an easy win. If they've been not so clever, then maybe we can pick that up. This is a built-in collector, of course. So we simply would write this in the real-time search screen. And if in this particular instance, we're going to get the command line output, and then we're going to focus it on a partial IP address. So anything that's going internally to one of the 192.168 addresses. Yet another built-in collector example would be using our network flow. Now, in this case, network flow is a feature that must be turned on as a part of your EDR client policy. So if you're not actually using network flow in your client policy, you won't get the ability to run this this collector. But if you do, then you can get information such as the status of connection, the protocol that it uses, direction, if it's in or out, source IP port, destination port, and other elements. I've only chosen a few of the examples just to give me a broad understanding of the nature of the connection. And then I have a where statement that allows us to see if there's one particular address that we're trying to track against. I have a note here that we would like to always combine these real-time searches with historical device searches. When you're thinking about command line history, you're thinking about network flow, there are caches of information that are stored on the clients that we can pull from. Of course, those caches can fill up. Those are either be caches that we build. For example, for network flow, we have our own database that keeps a history of information from the system when we turn that on. That could fill up after a certain period of time. It just depends on how active the system is. On the command line history side, there could be history that's set aside within the product or the operating system rather. And then operating system, it dictates how many lines of history. So however that cache is built from either side, that'll be the amount of time that you get with real-time search. But if you're looking to pull information historically that you've sent in the form of traces, so activities that you may have had occur on a system that will have the same types of read buffer information, then you can pull that information using our historical and device searches. And that way, combining the two, you can get the full spectrum of what amount of time that you could have possibly stored this since the client was installed. In yet another example, a little bit more of a sophisticated example, we're going to try to see if there is some methods to detect if WMI remote process creation is occurring. So a few collectors that I can suggest here is one, since it's a Windows system, and I'm looking to see if there are any ways that an attacker or a script has driven by and actually created a scheduled task, then we're going to use the scheduled task built-in collector to find information out here to see if there is anything that would show us that WMIC or any of the WMI components are listening for an attempt to connect to that system. We also have the ability to look at process history on this system. And of course, process history is yet another policy that you can enable within your EDR client policy on EPO that stores a longer cache of information than what could be gathered in real time. So in that case, if you do have that turned on, you can see if the WMI, for example, or WMIC in this case, or any of the components in WMI have been launched within that cache. We would also want to combine this for other elements in your threat hunt, such as understanding if a parent such as WMI VSE has been launched. And that would give us some indication that remote WMI has been invoked, and we didn't, maybe by policy we turned that off, but this would allow us to go and historically see if that has been disabled or has actually occurred in this environment. We can also look at other processes such as WINRS host, which is particularly implicated in remote connections. And then furthermore, we can do additional searches historically on connections over TCP through N35. And if you're using WinRM, which is not common, then we can see if there's any connections over those commonly known ports, such as TCP 5985 and 5986. Now, if we run into a wall and we can't really figure out from what you've looked at GitHub, what you've read in your product documentation, and you simply still want to do something that EDR can't do, then we have the ability to do custom scripts. Now, custom scripts come in exactly the same format that our built-in scripts come in. They either come in as a collection or a reaction, with the caveat that collections must output to the screen in some sort of common delimited format, meaning that when you run, like say, a PowerShell script or a Python script, whatever the output of that is on the host, because essentially you're running the script on the host when you're running a collection with our tool, then that has to come out on that system as a common delimited response. So that when we run it in our EDR cloud, it also gets represented in that, and it gets divided into columns so that we can show those on your screen. So just be aware when you're creating your own scripts, that's just one thing you have to create your scripts towards. Now, reactions don't have to have that output. They can either come as an success, failure, or they can return an error. When you write your scripts, if you have error handling, you may want to output those errors so that you can see those in logs, or we can detect those errors and possibly pass those to the UI so that you can understand what has failed. One thing to note is that if you're doing your own script writing or you're trying to something on the internet and you want to adapt that, of course you want to be aware of the language and understand what exactly that script is, but you can adapt those scripts. So if you're doing common tasks in the SOC with scripts that you've used, that you've downloaded from other places, then you can simply make some changes. And we'll see here in the next demo section that we've done that for one particular script. Another thing to note with these scripts is that there's an execution timeout value of 60 minutes on the endpoint. If something does not happen in 60 minutes, then you probably need some other method to acquire that information from the host. But for example, if you're trying to run something that's like in a reaction and you want to let it finish, you don't have to necessarily have this timeout value. It doesn't really apply. It just simply launches, and then as long as it launches and it returns the console back to you, and it allows you to continue that process in the background, then in that case, the timeout should not limit you. And the last thing to note is when you run a reaction, those are all tracked in action history. So if there's success, a failure, an error, that's all going to show up there and who ran it on the EDR console. Collections aren't tracked. So if there's any errors, outputs, what have you, they're all going to be seen in the real-time search screen when you perform the real-time search. So next demo, if you can zoom in on your screen, or when you do your replay, you can take a look here. But there's a Firefox extension PowerShell data collection script that's out there. So basically, the purpose of this script was to see what extensions are installed within my Firefox on any particular system. And in this case, I made one change to convert the output. This actually has been used with the customer. I made one change to convert an output to CSV, and then I made some changes to add outputs. So we're going to go ahead and start the demo here. See what it looks like. And so first of all, when we wrote the query, we have two conditions here. We have both the host info collector, which is going to tell us which system and IP it is, and then we're going to run the script itself. So the script has a underscore in front of it, and all custom scripts that have an underscore, essentially, that's how we determine that it's custom or not. You can't create one without that underscore. What you're seeing here is the output. So in the first couple columns, as in the order that you see in the query above, you get both the IP and the host name. And then all the other elements that you see here on the screen, the other columns, those are built in. So we don't actually specify a field within the request. We'll get everything. And so as a default, we got all the defaults here, which give us things like the name of the user that installed it, what the version of the extension is, the link to the extension, online, etc. Moving into another example. This is a example where you see the script on the screen. That is the script that we used and we designed. So in this case, we made some changes. So without the brackets or the braces here, excuse me, you could run this in PowerShell and it would return back information about what it doesn't return back, it actually sets the value of a particular key. In this case, this is the purpose of this one. This is going to be changing a registry key as in form of reaction. A few things to note. When we create the box on the right, we have to put the braces around each of the values in the PowerShell script to represent the fields that we're going to see in that box. So whatever that is, registry path, key name, you define those values. So these are here for you to define. Then you can throw that in here. I could have called this as easily as key underscore value or key underscore name or made it caps, whatever. Another thing particular to this script is that Microsoft, you may be familiar with writing out local key, or excuse me, H key local machine. Microsoft imposes on us that we had to put in this as H key LM. So when we run this demo, you'll see that that happen as well. So here, just before we start, we can see that this is an example of saved searches. So in this case, the saved search is going to be, it's going to show me all of the systems that have a particular registry key. So I'm going to go ahead and run that search initially, just to see if that registry key was set. In this case, this registry key is going to look at it's going to configure the setting to allow an administrator to do auto log on. And I highlighted it here. In this case, the value is 1, so it's allowing an administrator to do an auto log on, something we really don't want to have happen. Now I'm going to click that system, and I'm going to run a reaction on it. So I could have more than one system here. I could have a whole page of systems. So I could do the same thing too. I copied in the path, made a couple of changes, as we alluded to earlier about how Microsoft wants it set up. And then the reaction, it's almost instantaneous since the client's polling frequently. Now I'm rerunning that saved query, and I'm just going to see if that has changed the value from a 0 or to a 0 from a 1. In this case, it did. So it was successful. To wrap up on custom scripts, these are some examples from the field, meaning from professional services, as well as others that have used this tool. So sales engineers and other people in the community that are EDR fans. This tool, a tool has multiple uses. So here's some examples, some notable examples. I'm not going to read through all of them, but one is sending a file directly to ATD, or what we now call Intelligent Sandbox. This is publicly available. We can also do things like zip and encrypt and drop files to a share. Had an example of a customer who executed a third-party forensic agent from a share on a host, so they wanted to do something that the EDR doesn't currently do or is more of a niche product, and then we just simply constructed a script that allowed them to do that. Another feature here was using the Trellix agent to deploy software, make changes to a system. And in this case, we can set a custom prop using the EDR agent on that system. So we can give it a tag, and then from there, you can allow it to do all the automated processes that you've set up in EPO. That way, the SOC team didn't actually need to have someone get access to EPO. And of course, doing data collection on things that doesn't always get displayed right in your face in EDR, such as displaying alternate data streams within Windows. So a number of these, and these are all mostly created by professional services. So jumping into the next module here, this is using investigations and historical trace searches. This would be your introduction to our EDR AI. Via our guided investigations and the data enrichment features within that tool, and then the ability to import IOCs in bulk. So again, what do investigations and historical trace searches give me as a SOC analyst? Well, first of all, I want to use the power of the EDR cloud AI to help me make advanced assumptions about what I'm collecting. So we like to call this as kind of a tier 1, tier 2 type of activity, where we're going to take all this information and we're going to tie it together, so then visualize complete some picture of what's occurring. So this is the features that we're going to cover in the next few minutes are going to cover how we accomplish that. We want to be able to enrich the data with ENS threat detections. So we do that in some of our monitoring, and in some cases, the monitoring alert will happen, and then ENS may do a detection later on in the chain. And in that case, you may want to enhance the information that you've collected with that updated information. We also have the ability to perform endpoint snapshots. So again, if you create an investigation and there are changes to that system, then we can create a snapshot, and that will refresh what has been collected on that system. If you want to do compliance and vulnerability scans, the EDR client has this feature built in as well, so that you can collect this information. And then we can import and search IOCs in bulk across historical data, meaning we can take everything out there that may come from a campaign that you might get from insights or any other tip, and then use the power of EDR to scale that search across all of the systems so that we can complete some picture that maybe there's something occurring on a large part of my environment. The screen that you see here is the introduction to our EDR investigation feature, which allows us to do expert assistance in around creating an understanding of what's occurring. So in the form of investigation guides, which are questions that are led by us to come out with findings that will instruct you as threat hunters on what to do next. This is our way to start that investigation and continue on bringing in new data, enriching that data, and then answering those questions. When you're using this investigation feature, you have built in the ability to enhance and enrich the data that you're getting by bringing in ENS data from threat protection and threat prevention and web control. Some of your monitoring alerts may not have blocked and clean activities. So if you go through and do a review at the same time as that monitored threat, depending on when that threat was recorded and if it brought in the information about the ENS detection, sometimes that might not be in that particular alert. In this case, if you want to bring in that information and you're seeing that EPO at the same time that alert occurred did something to that system to block, then this will assuredly bring that into the investigation and create a investigation guide and a finding associated with that. Furthermore, if you're looking to update the information from the ring buffer on those systems, then this will allow the snapshot ability would allow us to bring in new information. So if we create an investigation and a couple of days later you wanted to learn more about that system and not rely on, say, an alert occurring again, then you can run a endpoint snapshot to record that and then update. We're not going to do an enrichment here because that does take some time to complete, but usually, it's not weeks or months. It's maybe a few minutes or maybe up to an hour in some cases, just depending on how complex the enrichment will take. Another feature that I like to use within EDR is the vulnerability assessment feature. You may already have an assessment tool, but this is going to allow you to leverage the client and the features that it provides to acquire things such as missing patches, exploitable vulnerabilities, installed patches, and then do a vulnerability assessment. Our vulnerability assessments are based off of the CIS critical security controls. So in this example here, we're looking at one of the policy settings on the system so that maybe we want to understand that when we had an alert or we had something, what is it that it's about that system that allowed it to be exposed? And in this case, this might be one of the elements here as far as WinRM that might be implicated in whatever the exploit is. Then moving into our historical search features, now that we've completed some of the picture within the investigation, maybe we want to go out there and we want to find some other systems that might be a part of this. Whatever the event is or the behavior that you're looking for is. So you can use the historical search features to construct that additional list of systems, and maybe you want to treat them similarly in the investigation or use other tools to perform reactions, execute playbooks. So this is going to allow us to pull those IOCs in bulk. We input that validation. So you can either provide MD5 hashes or SHA-256 hashes. And this is all against your historical trace information. This is not against real time. There are features, of course, that allows us to search in real time if there is something still on those systems, but this would tell us if those files were created, if they were cleaned by ENS or what have you, get deleted. Okay, and our final topic, we're going to cover the Trellix native and external API integrations. So when thinking about what you can use EDR with in your whole Trellix ecosystem, we're going to discuss what opportunities you have with your own Trellix products today that you may not be aware of, as well as our Trellix API. And then the API, of course, could be used possibly with other applications that you may use in-house, such as SIEM, SOARs, and other tools that you may be using as a part of your full defense. So when thinking about your Trellix native and API integrations, what are some concerns would I have as a SOC analyst? Well, first of all, if I'm in the position of being a SOC engineer, I want to be able to quickly build and test custom API integrations using a document supported API. We offer that with this with our Trellix API, and especially with the EDR. Then what if we want to realize benefits of our own Trellix products as they integrate with EDR? We have those capabilities laid out in the next few slides. What products do we currently integrate with? Well, this is a list of all the products today that EDR has some sort of integration with. You may already be aware that EPO is the coordinating component. It manages policy and authentication and the ability to perform things such as enrichment that we spoke about earlier with ENS data, and also manage DXL communications. But if you haven't used tools like Insights, which allow us to provide correlations with campaign data that we record as part of that product's feature, or the fact that TIE and GTI will enrich EDR information with reputations, then this is going to be helpful for you to justify some of these other products and how they all can relate to each other. For instance, we have two SIEMs or SOAR SIEM products, such as our Trellix Helix and ESM platforms. And in both those platforms, EDR is a data source that can be ingested. I will mention that any automations or integrations back into EDR will require an API subscription with our Trellix API, as we'll discuss in the next slide. When using the Trellix API, currently we can access the API and get information about the API. It is a Swagger based API, so very nice to use and easy to explain to those API developers that may already do tool development in your organization. With our API, we have the ability to extract EDR events. We can create investigations and update those investigations. We can perform real-time search, and we can also include things like executing reactions as a part of those searches. What you'll see in the next demo is an example of using the Swagger interface so that you can quickly demonstrate, you can quickly build these integrations on your own. So first of all, we're going to log into the portal. The portal is going to have more than just our API for EDR, but it's going to have other APIs. We're just going to, in this situation, or this example, excuse me, we're going to make a change to an investigation. We're going to change it in name, and then we're going to leave all the other defaults. But the outcome here is that we're going to create an investigation that's going to have a high priority, but we haven't assigned it yet. So we're going to execute that. It creates a curl that you can use in tools such as Postman, or you can just run the curl without that. Just validate that JSON, return back with its success, and then Inside of EDR, we're going to see that we've created the investigation, the name that we set within the API. And it's as simple as that. It actually was done all in real time. So it is as quick as what you see here. When you extract the events from the API, you may wonder, what is the information I'm going to get? What can I use with it? Are there other examples of scripts out there that have been made by Trellix or are supported that could help me integrate with this product? The events will contain IOC information, such as process name, severity, a link to a URL that's within the EDR product, so you can jump right into the event itself, the execution time, and the EDR rules that are triggered. With this information, you can use this to act as a guide for your SOC analyst to investigate manually or launch further EDR integrations. We do have, I do promote here that professional services does a number of these, as you saw the examples earlier that we've created. But you do have the ability to leverage supported integrations within our Trellix GitHub. So it's the same location, but you just need to search for MVISION EDR activity feed. And we also have a former sales engineer named Martin Ohl, who has kept up a supported site under GitHub with scripts that allow us to integrate within EDR and other tools. I would say that this is a good starting point for a number of my scripting efforts and yours as well, hopefully. Maybe here, I would just it is as is at this time, but the bulk of the scripts are still yet supported. A few API integration use cases that we see here. We have, of course, using built-in and custom reactions against hosts using playbook automation. So, for example, we want to send files to intelligent sandbox, quarantine a host, kill process, etc. We may want to create or query an investigation within EDR. And then finally, we may want to perform a search using real-time, historical, or device search. In this final demo, we're going to see how we use insights as a part of one of the Trellix integrations. So we're going to see campaign hits. We're going to perform a real-time search on IOCs, and then we're going to finally look at our manual playbook feature within insights as it relates to EDR. So as we start in the insights interface, we're going to pick one of the campaigns that has systems. So at random, we're just simply going to come up with some systems that may have some hits on detections. In our first detection, we see that ENS is one of our detectors, and it came up with a hit on one of the campaigns. In another, we have yet another campaign that we highlight here, Operation LoJack, where we both detected ENS and EDR. Of course, there's a number of these that I didn't show you that are simply EDR detections, but in this case, you have two products that may detect at the same time. Now, if I want to drill into a campaign in specific, I'm going to pick one here, Taskmaster's APT. You'll see here there's a heat map, some IOCs that might be a part of the campaign, and other information. I'm going to drill in on the IOCs, and then I'm going to simply use the features within Insights to perform a search. As you'll see here, we can do up to a search up to 10 IOCs, and they must be file IOCs. Domains and IPs aren't included as of this date. So what will occur here is this will actually open up a screen into EDR, and will form that query for you. We could go in and search. We're not doing that now in this demo, but moving over into defensive playbooks, we're going to pick the defensive playbook for Ryuk ransomware. We have three elements of any playbook campaign. We have before, during, and after. And I can focus in on the visualization and find where I want to focus in on as far as the order. But in this case, we're going to look in the during. And in this example, I'm highlighting that EDR is a part of the playbook. It's one of the components that we're going to use. There are multiple methods for this particular threat or behavior that occur. We have an assess, configure, and other sections within the assess, configure, validate, excuse me, and monitor. And in this case, we highlighted the fact that there are areas here that we can use in EDR to follow instructions, and where you can use the tool directly to execute against that playbook. And furthermore, we're taking a look at yet another countermeasure. We're going to assess what we need to do with EDR. In this case, there's an actual real-time search that we can perform. We can copy out of here. And then finally, not going through any of the other sections, but you should get a pretty good idea of what the playbook does. We're going to add a note here to complete that task and declare it done. So to wrap up this webinar, what do we come back with from what we discussed over the last few minutes? First of all, EDR is extensible and can be made and fit into SOC processes via support of built-in and custom data collection, reaction scripting, and APIs. EDR can help SOCs scale efforts beyond a handful of endpoints using fast automated searching capabilities. And then finally, EDR supports multiple Trellix native integrations with little effort out of the box. When used together, you can speed up your threat hunting, convicting, and share intelligence amongst your coworkers and other applications. Back over to you, Nick.
Thanks, Matt. As a reminder, Trellix Education Services offers exceptional training to go along with our award-winning products. If you would like to learn more, please visit the website listed on the screen to see all of our offerings. Now let's get our Q&A session started. I see we have several questions, but it's not too late to add your question. Please type it in the Q&A window to submit. Additionally, take a moment to fill out the survey. Your feedback and suggestions are always appreciated. RTS is dependent on the Windows script host to be enabled. Is there an alternative available if we disable WSH for security reasons?
Yeah, so unfortunately for the built-in scripts, they are dependent on being able to run those, because the majority of them are running PowerShell or OS commands. But conceivably, and I haven't tested this, but if you did install the Python client on those, I believe Windows scripting host is not reliant upon that. So unfortunately, that would only really address the custom scripts that you may create.
Got it. Okay, cool. Thank you for that.
Mm-hmm.
Can we start an investigation out of the blue without an alert to take action on?
Certainly. Yeah, that actually can happen. So you can either do that via the API or the UI itself, and you simply go into your investigations, just create a new investigation, and then you can add any of the systems that you currently have in EDR, meaning with an EDR client. You can even add in external IPs. So if there was something that did not have EDR, if there was some information that was related in traces to that IP, it could be part of that that investigation as well.
Got it. Okay, perfect. Thank you for that. Is there an option available or plan to trigger an event if a new EDR alert is available, maybe an API option?
If you use the activity feed scripts, either on our Trellix's official GitHub or the gentleman's GitHub that I mentioned in the webinar, there is, of course, could be a way for you to use that information to generate events. So when you're referring to generated events, I would assume you're meaning within EPO, possibly, but I'm not sure from the question how it's phrased. But essentially, I have seen instances where we can create events in EPO, and also this could be something that could be used in, say, a SIM.
Got it. Okay, cool. Thank you for that. Can Trellix EDR be run in a closed, air-gapped environment?
Unfortunately, without it does have some connectivity. So the answer is possibly yes, meaning that there is ways for us to accomplish that. Dependent on how you design your DXL broker infrastructure. So if you're truly air-gapped and you're not able to reach out to our cloud at all, then the answer is no, unfortunately. We still do maintain our active response, which is basically the earlier version of EDR, so you can still use that at this time. But as far as an air-gapped environment, if you do have a path out to a DXL broker and EPO, which would actually give us the route out, then you could have an air-gapped environment with only those paths internally, and then they could communicate out, and you could do all what you need to do with real-time search and traces, etc. through that.
Okay, perfect. Thank you for that. It looks like that's all the questions that we had for today's session. I want to thank everyone for joining today's webinar, and a big thank you to Matt. As a reminder, a link to today's recorded presentation will be emailed to all registered attendees. This concludes today's webinar. Stay safe, everyone.